Okay, I was asked to explain this little system that I put together. So it's based on the idea that for every chord, is there a shorthand way to remember what intervals are played in a chord? So for example, in the upper left here, here's an E shape major chord. It's got a root, a fifth, another root, a third, a fifth, and a root. Or more simply, it's got a root, a third, and a fifth. Okay? And the same thing is for an A shape major chord or a D shape major chord. For all the major chords, there's always a root, a third, and a fifth. They're just played differently depending on the shape. Okay? So another way to think about this is that, and this is from one of Steve's tables, is there's obviously a name for every interval off the root. So in this case, if the root is A, on the first line, an A to an A is a unison, an A to a B flat is a minor second, called a minor second, or there's an alternate name called a flat 2. But the important thing to me is, if you look to the right, it's half a step, or one semitone. So what bothered me about all this is that there's an interval name for all of these intervals. They could actually be used to an alternate name, and there's really no common sense of it, in my opinion, when it really is just a set of, on the right, semitones. One semitone or a half step, two semitones or a whole step, three semitones or 1.5 steps, etc. So my question is, why do we complicate all these things with knowing words like flat, sharp, major, minor, augmented, diminished? It turns out there's 19 different terms to describe just 12 intervals, and in many cases use the terms multiple ways. Okay. So the simple thing is, why not just use half steps, or as I like to call them, semitones? All right. So triads in the fourth paragraph there. Triads are just a series of semitones. If X is your root note, for a major chord, you always play a major third, which is 4 semitones. So X47 means play the root, play a tone 4 semitones above that, and a tone 7 tones above the X. That's a root, a major third, and a perfect fifth. So an X47 is a major chord, where X is the root, 4 is a note 4 semitones above, 7 semitones above, etc. X37, etc. And that turns out to be this simple chart. So in the upper top here, this is all in E shape. For a C chord, my nomenclature is, well, a major chord is always an X47. That means it's a major third and a perfect fifth. The examples in the C chord are C, E, and G. There's the chord, there's the intervals on the right. Now, the whole reason I did this is the blue column. So it's very easy to remember what various chords are made of. A major chord is an X47. A minor chord is an X37, which is an easy way to remember. Oh, you just take that major third and you drop it 1 semitone or 1 step on the guitar fretboard, right? And you can see that in the pictures. Or a dominant seventh is a major chord, X47, and I put -2. I have to give this to one of my tutors. Rather than saying, it's just to say two semitones off the root, or back down from the root or from the octave. So you play a 4 semitone note, a 7 semitone note, and another note that is 2 semitones back from the octave of the root. 47-1, same thing, 37-2. It gets interesting, like when you look at sus2 or sus4. I always got confused in those things. You just play a root note, another note that's 2 semitones above the root, another note that's 7 semitones above the root. That's a sus2. So I don't use these all the time, but it's an easy way to ask yourself, what is really being played if you don't want to remember all the major, minor, flat, perfect, minimum, diminished, sus, blah, blah, blah. If you just remember the X system for any chord, it's either 47, 37, etc. It even helps me when I think of different seventh chords, because I can remember which kind of bass chord is played off of, a major or minor, and then 2 or 1 back from the octave. It seems a little strange here, but the funny part was when I talked to ChatGPT about this and said this seems like a just simple mathematical, very forget nomenclature, very mathematical way to say what is a chord made of, and it just write it down in the semitones of the notes that are in the chord, and you can keep this shorthand way. You can even get rid of the X if you wanted to. And so there's just a very few numbers that you really have to know to understand all chord structures, at least not all the major chord structures, but this would continue for anything you want. Anyway, that's it.